Welcome to Stage 03. This is where Fail2ban stops feeling like configuration and starts feeling like pattern matching. So far, you've set up jails, what triggers them, how long they ban, how to coordinate many at once. Now we go one level deeper into how filters actually match the log lines that trigger those bans. Filters are just regular expressions in a tiny Fail2ban specific dialect, and this lesson is the foundation. Lesson 08 will build real production filters on top of it. And here's the one piece of Fail2ban specific syntax you actually need to learn: the placeholder. Standard Regex has no concept of an IP address, so Fail2ban gives you this single token. Drop it into your fail regex wherever the IP appears in the log line, and Fail2ban handles the rest. Take this sshd line. You write a normal regex matching the surrounding text, put where the IP sits, and internally, Fail2ban expands it into a complex IP matching pattern. The result is a matched line plus an extracted IP, everything the firewall needs to issue a ban. Now, with handling the IP, the next habit to build is anchoring. Almost every Fail2ban filter starts with caret.plus, and it's purely defensive. Look at the left side. A regex that starts with failed password tries to match from byte 0, but byte 0 is /29, a timestamp, so the filter silently reports 0 matches. Add plus on the right, and that greedy prefix eats the date, the host name, the process tag, everything up to the part you actually care about. Same log line, same intent, but now it's portable across distros whose timestamp formats will inevitably differ. With anchoring handled, the next building block is character classes, the alphabet of regex. 5 shorthands cover almost everything you'll write: ND for digits, RW for word characters, NS for white space, the bare dot for any single character, and square brackets for your own custom set. 2 warnings worth burning in. RW includes underscores but not hyphens, which bites you on usernames, and a bare dot matches anything, so always escape it with a backslash when you mean a literal dot in a domain or file name. Character classes match a single position. Quantifiers tell the engine how many positions to repeat. 4 shapes cover everything: star for 0 or more, plus for 1 or more, question mark for 0 or 1, and curly braces for an exact range like 1 to 3 digits. The catch is greediness. By default, plus and star grab as much as they can. Notice how dot plus from on that log line swallows everything up to the last from. Adding a question mark makes it lazy and stops at the first match. In Fail2ban filters, that distinction is the difference between capturing the right host and capturing half the line. With those mechanics in hand, here's the working vocabulary. 6 patterns cover almost every filter you'll write. Is the only Fail2ban specific one. It captures the offending IP, exactly once per line. The rest is standard regex, RD curly 1,5 for ports, DARW plus for usernames, the bracketed word.hyphen class for FQDNs, a negated class inside quotes for user agents and URLs, and a non-capturing group for HTTP verbs. Memorize these 6 and you can read most filters at a glance. Now let's put those patterns to work on a real file. This is sshd.conf, the filter that ships with Fail2ban, broken into its 3 sections. Includes definition and init. The definition is where the action is. Fail regex holds 1 or more patterns, and a line gets flagged if any of them match. Notice the shape, anchor at the start, the literal text Fail2ban looks for, then where the IP lives, and a clean end of line. Every filter you'll ever read follows this exact skeleton. Knowing the skeleton is one thing, proving it works is another. Never edit a filter and just reload the daemon to see what happens. That's how you ban yourself, or more quietly, ban nothing at all. The tool you want is Fail2ban Regex, and you'll use it in a 3-step loop. A quick sanity check piping a single line through an inline pattern, then a run against a real log with your filter file to see how many lines match, And finally, the print all matched flag, which shows you exactly which IPs would have been extracted. That last step is the gold flag. If those IPs aren't the attackers, you're in the wrong place. Now, once you're testing with Fail2ban Regex, you'll quickly run into the same 3 mistakes that break most filters in the wild. First, catastrophic backtracking. Nested quantifiers like plus force the engine to try every combination, and a single long line can freeze a core for minutes, so prefer a flat on D plus over on D plus plus. Second, the forgotten peaked plus anchor. Your regex looks correct but matches nothing because real log lines start with a timestamp, not your service name. And third, unescaped dots. A bare dot matches any character, so logfile.ext happily matches logfile.xtext, and you ban the wrong IP. Escape your literals, anchor your prefix, and keep quantifiers flat. So let's put it all together with the workflow you'll actually use. Step 1. Grep a real offending line out of the log. Here, an nginx 401 on API ars login. Step 2. Locate the IP and mentally drop in its place. Step 3. Generalize the parts that vary. The timestamp becomes DACRUS. The request becomes Y+. The byte count becomes D+. Step 4. Anchor it with aquas and doppers and run Fail2ban Regex. 73 matches, 0 false positives, ship it. That's the whole job. So let's recap what you've actually picked up. 6 skills. Place exactly where the IP sits, anchor with byte+ to skip the timestamp, know your 5-character classes, pick quantifiers deliberately, read the standard filter file layout, and validate everything with Fail2ban Regex. The real win isn't memorizing syntax. It's that next time you open someone else's filter, you can read it top to bottom and explain every token, instead of copying it and hoping. And that closes Lesson 07. Regex is no longer the scary part. It's just the language you now speak fluently when you look at a Fail2ban filter. In Lesson 08, we put it to work. Writing a real filter for nginx 401 brute force, handling multi-line matches, ignore regex, date pattern, and shipping the finished file into filter.d. Bring what you learned here. You'll use every piece of it.